Hello, in this video I will show how to use Python code to automatically identify interstitial positions in a crystal structure using either the Voronoi or charge density methods, and how to place certain number of interstitials of some element at the positions which are either the farthest from each other, the closest to each other, or something in between those two. This can be beneficial, for example, as a starting point when searching for the configurations of such interest point effects which has the most preferred, which are, let's say, the most energetically preferred. Okay, so the code can be found on the implant website here, and it is on GitHub. So if I open this link, it will lead me to the code. And the description on how to use this code is also written on this site. I will illustrate an example on supercell of titanium dioxide. So I already prepared the structure in postcard file, and if I open it, it looks like this. Not this, like this. Okay. So let's suppose I want to place 5 interstitials of nitrogen into it. I will use the Voronoi method. If I would like to use the charge density method, I don't need the postcard file. This I need for the Voronoi, but I would need the charge density file which corresponds to the postcard file from WASP calculation. Then I have this Python script here. So let's first take a look at the user settings in this script. The user settings is here. So I need to define which elements to place as interstitial. In my case I want nitrogen, and then how many interstitials I want to place. So let's say 5. And then if I want to use as possible positions for the interstitials either all the positions which the code will find, and if I want all, I will set here 0. But also I maybe just want to place the interstitial at certain type of unique interstitial positions. So let's say the code will find, for example, 2 unique interstitial positions. Each will have its own multiplicity, and if I want to place the interstitials only on the first type of unique position or the second type, I will write here either number 1 or number 2. In my case, I already ran the code before, so I know there are 2 unique interstitial sites, and I want to place these interstitial only on the type number 1, not all of them. So I will use number 1 here. Okay, that's all from the setting, from the user setting. I will save it, close it, and I can run the code now. It will take like 30 seconds to finish, so let's just wait. And of course the code also takes into account periodic boundary conditions. Yeah, so this is the output from the code, and it found 1 unique interstitial site at these fractional coordinates, and this site has 64 multiplicity, and all these 64 equivalent positions are listed also here with fractional coordinates. and then it found a second unique interstitial site at this fractional coordinates, and this one has multiplicity of 8. So I chose in the code that I want to place the nitrogen interstitials only on the first type, so only on these either on these available 64 positions. And the code save the outputs with the interstitials in POSCAR and also CIF format, and all three variants. One which has the farthest distances between the interstitials, one with the nearest distances between the interstitials, and one with something between those two options. So in this folder I now have all these modified structures with interstitials, and if I will take a look how they look like, so let's put it into Ovito. Yep. So this one is the structure with the nearest distances between the interstitials, and it looks like this because it takes into account the periodic boundary conditions. The second one is with the farthest distances between the interstitials, and the third one is something between those two options. Yeah, so this is how to run the Python code to automatically identify available interstitial positions in certain type of structure, and how to automatically place some number of interstitials of some elements into the available positions. Thank you for watching.